digging deeper into how data is used, there are obviously a lot of tools that people use. I, for one, use only a certain amount of tools in my role now. There's some that are more commonly used, like the ones that I'm going to mention, but there are others that are important as well, but are very industry or role specific. So it also depends on the company that you stay at, the work that you do, the level of analysis that you use. Say, for example, you're into statistics talaga and you want to dig deeper into all the numbers that go into your analysis or that go into your model. When you make models, you make use of very convoluted, very complex statistical models that not the average person would recognize. So you would have a certain tool for that. You would have a certain language for that. So these are the three programming languages, or the three languages that I generally know to use on a daily basis, and these are the some of the more commonly used tools. So the first one is called SQL or SQL. Its definition is structured query language. So it's very fundamental and one of the more commonly used, or one of the most commonly used actually, tools and languages in the most large scale companies. So if you work in a very large FMCG or multinational company, more often than not, what their data team uses is SQL. It's also what I use for work now. So that's the language I use for work because I work with a lot of large databases. And the function of this is for database management, basically. So it's to prepare the data that you have for the first of a three-step process called ETL. So the first is extract, then the second is transform, and the third is load. So it's called extract because you're taking the data from a sort of reference point. For example, you're in a certain server, and the data engineering team creates a bunch of tables that you can use based on the function. So, for example, one table is for all the transactions that are done on a certain day, or another table can be a list of users that you have on your platform, or another one could be your list of campaigns that you're putting out on a daily basis. So you extract data from all of these different sources and you transform them. So you reference these tables, you join these various data tables and transform the data that you have by selecting the columns that you need, manipulating and computing. So say, for example, you have all the transactions from month one to month two. So you want to summarize the total number of transactions from month one and month two. So that's basically transforming the data that you have from a list of other transactions into a summarized data point that you have. So, for example, month one had 20 million transactions, and month two had 21 million transactions. So that's how you basically summarize these things. And then once you have that final data that you have all the columns that you need, you have all the data points that you need. That's where you load it onto a visualization tool, another presentation tool. So if you're familiar with Power BI or Tableau, that's where people load it into. In some companies, they have their own visualization tools, and you can even load it into the other tools that I'm gonna talk about later. So that basically gives you a way to manipulate and take all of the data that you have and put it into a singular database that you need for your analysis based on your understanding of the problem and based on what you want to get from the data. The reason for people using this is it's very simplistic, and it allows you to manipulate very large data sets at one point in time. So for example, if you work in e-commerce like I do, you work with millions and millions of rows of data every day. So if you don't want all of that to load multiple times, you're able to get the information from an online server, and you are able to manipulate that, and you're able to compress everything into a singular database with all the things that you need, which is generally a lot lighter than putting all of those data sources into one large table. Another one of the most used languages in the world, not just for analytics, is called Python. So this is the one that you're probably the most familiar with. It's used a lot in shows. It's used a lot to reference mga hackers, ganon, because instead of being an analytics language, it's more of a general purpose programming language with analytics capabilities. That's how I would say it. It gives you a way to automate your things. So it's used mostly for automation purposes. If you want to do things in one fell swoop, you can do that using Python by putting all the functions that you need, all the data that you need, and it even allows you to get input and then use that input to manipulate the data and use it for to return an output. These languages, they make use of packages to make life easier, as will another programming language that I'll explain later. So well, packages are basically scripts, they're functions, they're already put together code that you can easily reference to use in analysis. So these are open source. If you're familiar with that term, it's basically a term that describes software, describes information or tools or utilities that you can use from anywhere, from without anything blocking you. For example, if you need a subscription to have this, it doesn't require you to do that. Everything is available and out in the open for you to use. So an example of this is something that I used before. When I was living in the States, I was trying to look for furniture. I was trying to look for things that I wanted to buy that were cheap, like say for example, a bed frame or cameras or um, things I can use for my computer, another monitor, and things like that. So obviously, if you're looking for things online, it generally takes a lot of time because you have to canvas every single listing that there are, especially in when it comes to secondhand markets like eBay or large marketplaces like Facebook Marketplace and Carousel and stuff like that. So what I did was I was able to get Python code from someone on the internet. He was able to share it, and I downloaded it, saved it, and ran it on my computer through the command prompt or other platforms that you could use to run Python. And then it prompted you to enter a search query. So it prompted an input from me. Say, for example, you're looking for a PlayStation 5. And after a few seconds, after you enter that information, it returns CSV or an Excel file with the different data points on the available listings on eBay. So the name, the price, the location, whether it's an auction or a fixed price, the link. So you can choose there what the lowest prices are, what the most reputable one is, where the nearest one is, and stuff like that, without having to look through all the thousands of listings from there. So from there, you can manipulate that and even visualize it. You can limit it to ones that you're interested in, filter everything. So it can take in different data sets, it can visualize, it can even do machine learning on Python and everything in between in the realm of data analytics. And the last one is the one that I'm personally the most comfortable with is R. So it's a single letter R, and it's commonly used on a platform called RStudio. So basically, RStudio is a way for you to use the R language more accessibly and more in a more user-friendly way. So how you download this is you go to the RStudio website and you go to products, RStudio, and then you go down to get RStudio desktop if you're working locally, and then you just download it through there. You can use it on Windows, you can use it on Mac or any other OS that you're using. So it's an open source tool that you can use, and this is basically what it looks like. In this language, instead of being an automated way or an automated language that you can use in one fell swoop, on RStudio, you're able to view the steps that you're doing in a very user-friendly way. So R is used mostly for statistics, for machine learning, for econometrics. So if you're an econ major, you're probably familiar with R. It's very similar to Stata with the results that you can get on a very easy way. But you can also utilize this to manipulate or manage data, as I'll show you later, visualize, or even build presentations and web applications. No? This one makes use of packages as well, as I explained earlier, so it depends on your need. So you can have packages to load data sets, you can have packages to provide functions for data management, machine learning, visualization, even web development, or even just basically loading colors that you're going to use for your graph. You can have packages for that. So for me, it's the easiest to use, especially on RStudio, because you can run things step by step and overwrite as you find mistakes or things to improve on. Something that I have as a pain point with SQL or SQL is that you have to run everything, which is basically millions of rows of data, before you can troubleshoot it, and it takes up a lot of my time. So this is one tool that I use, especially if you're using a very small data set. It's one that's very easily used. The language is very easy to understand because it's very straightforward. And yeah, so it can be done on Python as well, but not as user friendly as R, as I would say. But obviously, some people have their preferences. But I'll be able to explain why it's one of my most used tools when I go through this. So if you go through this, you can obviously see the entire user interface now. So when you have RStudio downloaded, it will most likely look like this, with give or take a difference in colors and size and everything. So what you want to do usually is you open a new project. So this one is called the Office. I'll explain that later. And you can open new projects or open new projects. You can open new files. You can open an R script, an R notebook, R Markdown. R Markdown is something that you can Google or you can message me about. It's basically a way for you to make all of your code into a single document. I'll demonstrate that in a bit, an output at least. And you can make so many different things from this. So you can even you can even integrate Python scripts, SQL scripts, JavaScript files, HTML files, C++ files. You can make your own web app based on or within this tool. No? So what we're gonna do today, or what I'm gonna walk you guys through today, is how to go through a simple data manipulation and visualization process. What you do on R basically is you install packages and you make use of these packages to go about your analytics process. No, so what I did here is I installed a package. So if you're new to RStudio, none of these things that I'm loading will be in your network, or basically your database of packages. So you will have to install all of them. There are a lot of resources where you can learn the basics of this. So this is basically a summary now. So as I mentioned earlier, packages are extensions to the R language, so they can be code, formulas, functions, data, documentation that can be installed and used. So this one contains the complete script of The Office, if you're familiar with that show, in a summarized format. So I'll be able to show you how that looks in a bit. This one, dplyr, it's a package that allows you to manipulate or manage different data sets. So if you want to summarize something, if you want to arrange in certain ways, you can use this. You can use this package. Tidy text is a package that allows you to manipulate text for simpler analysis. So for example, you have a script, diba? You can split up the script into different words. So one row per word. And you can also eliminate words that are unnecessary or irrelevant to your analysis, like filler words. And the last one that I used is a visualization package called ggplot. So that's a package that allows you to visualize data in different ways. So for example, you want to show a line graph, a bar graph, even 3D graphs, or time series, or if you want to split things into certain ways, you can use this package. So once you load these packages, you can, at least for this package, it's called Shroot. You can load a data set from this one. You can also load data sets in other ways. So for example, you have a CSV file. You can use dplyr, or you can use other packages to load in that certain file. So you can load in any type of database file, whether it's from Stata, whether it's from Excel, whether it's from a text file, or anything. You're able to load that through R. So once you install everything, I'm gonna cancel this because I already installed it. You can load your packages, or you can load them at once by highlighting and pressing Control or Command Enter. And then this is where I load my database. So once I run this code, this line of code, it loads into this environment where you can get all your created data sets for that session. No? For example, this one is called Office. So this one is a data set with 55,130 rows with 12 columns that have one row per line said on the show. So for example, in index 1, it's a line from season 1, episode 1. The episode name is Pilot. You have the name of the director, the writers, and the character, and the text, and then the text with direction. Text with direction is irrelevant, but in this case, it's basically the script with stage direction where you want to go, what that episode got on IMDb, how many total votes it got, and when it aired. So there are different kinds of data here. So obviously the numbers here, they're numeric columns, no? And for columns with words, they're character columns. And here you get this one, since it has different characters that you can limit to a certain amount and you want to categorize maybe later on. You can This can either be a factor column or a character column based on how you want to use it. Obviously there are numbers, and then you can also have dates and other types of data points. So this one, it's just a workaround that I needed. So this basically negates or does the opposite of this function called in. I'll explain it more later on, but it's just to create a new function basically. So you can also do that on R. Create new functions that you can use later on based on existing functions that you already have. So first thing that you want to do, of course, is to explore the data. So that's what we did earlier, no? So we want to see the characters with the most lines. So what you do is, if you have dplyr or tidyverse, it's another package that has all the data manipulation or data management packages that you need. So you get the initial data set called office, and then you use this to perform various functions on that data set. So every time you do a new function, you have to put this. I forget what it's called, but you use it generally for that. There's a lot of documentation on this as well. Obviously, it takes a lot of time to explain all the syntax that comes into this. But this is basically how what's possible in using this platform or this tool. So you can group by character and summarize each group by counting the amount of rows or the amount of lines that you have. So as I said earlier, each row is a certain line that was said. So if you want to find out which characters had the most number of lines, you could summarize it through that. No? So you run that lang, and then you have a new data set that has lines per character. So these are the number of lines per character arranged in descending manner of the count that you have, no? The line count that you have. So as you can see, Michael has the most lines out of everyone in the entire series with 10,921 lines. Dwight is next at 6,847, and so on. Then from there, you want to see the top 5 with the most lines. No? So you get that second data set that you made, and you make another one called top 5 lines, or however you want to call it. And then you arrange it again based on descending count, but this isn't necessary since I was able to do this already before. It's just a foolproof way of doing it. And then you get the top 5, which is the function top n with the number of entries that you want in the end. So after you run that, you end up with a data set of just 5 rows with the top 5 the characters with the top 5 number of lines in the series. And then if you want to make use of the top 20 with the most lines, this is what we're going to use in the visualization later. You just do the same thing and replace 5 with 20. One thing that you can do here, if you have data with a lot of lines, with a lot of words, or if you want to do text analysis, like I mentioned earlier with social media, you can manipulate the text. No? This one, I'm prepping the data by selecting all the columns without the one that I don't need. So it's the text with direction. This is not necessary, but if it's not necessary in your data, you don't have to include it. So you can just exclude it with this function. And then this unnest tokens function, it comes from this package called tidy text. What it does is create a 1 word per row distribution. So after I run this, it'll lead me to another data set with 570,450 rows with 11 columns, since I excluded one from the one earlier. No? So this one separates all the lines in text, the column text by word. So you have all, right, Jim, your quarterlies, etc. No. So that's all 1 word per row. And then what you want to do next is if you're doing text analysis, you obviously want to exclude filler words like or yeah, hey, uh, ah, all right, because that's generally not going to give you a lot of insight on your analysis. No. So you make a list of that. So if you want to make a list, you add C and then you put everything that you want to include as characters within that list. So this one is called remove. Then if you want to get the top or the most commonly used words without using the extra words, you can count or you can summarize it by using the function count by the number of words and then you sort it. So it's counting the occurrence of the words in the data set. Anti-join is basically removing all things that you want to exclude from a certain data set. In this case, it's stop words. So stop words are basically a set of commonly used words in a language. In this case, it's English. So it gives you a list of commonly used words that don't have a lot of relevant input in your analysis. So like if someone says I, or someone says you, or other stuff like that, this one removes it. And then you also filter it by removing, or you filter the words from here, because when I pre-made this, I realized that there were some words that were included after filtering out the stop words that obviously weren't important to your analysis. So I filtered that out. So this is where I input the function not in. So it's removing everything that's not in here, or it's including everything that's not in here. No? And then you arrange it based on the descending number of occurrences, which is n, because when you do count, it automatically inputs it as a column named n. And then after that, you get the top 10 words. I just wanted to limit it because there were a lot. So if you run this, you're going to end up with this data set that has the most number of occurrences for certain words that were said in the script. So Michael was mentioned the most times, Dwight was mentioned the second most times. Other than the character names, the word time was mentioned a lot of times. Guys, people, God, day, and love were part of the top 10 as well. So top 10 words per character are also some things that you one of the things that you can do if you want to summarize, if you want to see if the script writers were fair, or what the story goes, or how the story goes and stuff like that, or who the main characters are if you want to find out. Basically do the same thing, but instead of finalizing it at that, you group it by the character and the word. So you group by the character. So for every character, these are all the words associated with that character. And then you summarize it based on the count of words, or the count of occurrences of the words that you have. So that's how it summarizes, or that's how it aggregates everything. So you're limiting it to characters with the top 5 most lines here in the data set that we made earlier, called top 5 lines. Because there are so many characters, obviously you don't want to look at everything. It gets the top 10 words per group, and then it arranges it. You can arrange it per character, and then a descending count, just so everything is organized and you can view everything from the top down. So if you run that, you have the data set called words per character. So the character Andy, he says guys the most amount of times out of all the relevant keywords in his script. He says time because he sings closing time a lot of times, so it's mentioned a lot in the script. He mentions Dwight a lot. He mentioned Aaron a lot because they used to date. Spoiler alert. Dwight mentions Jim the most amount of times because they're always arguing, they're always playing pranks on each other and stuff like that. So it generally gives you an overview of the most interactions, the most used characters, or the characters with the most lines, etc., and stuff like that. So if you want to move on to visualizing, there are a lot of ways that you can visualize this kind of data. I'm going to walk you through the possibilities later, but this is just a simplistic way of how you do it. So what you do is you use the package that I mentioned earlier, ggplot2, and you manipulate the data set based on the data that you want to load. So basically, like I mentioned earlier, there's extract, transform, and load. So it's not only done on SQL, it's done on every analytics programming language that you use. So this is the extracting, you got the database, the transforming is done here. So for example, you have the full data set again, and you filter it based on whether the character is in the data set that we have for the top 20 characters with the most lines. Then you group it by again, by character, by season, and then episode, because we want to see the average or the count later on, and then the average of the number of lines that they have for that certain episode. No? So if you have this, you basically have a data set of the number of times the character had the dialogue on that episode. So for example, Andy in season 9 episode 16, he had the most lines he ever had on any episode of the series with 83 lines. If you go to Angela, for example, she has the most number of lines in season 9 episode 8 with 52. And then moving forward, if you want to visualize, basically the thing that I want to visualize here, I forgot to mention that earlier, was the share of dialogue throughout the series. So if you want to go through seasons 1, 2, 3, 4, 5, 6, 7, 9, you want to see the average number of dialogue that they have per episode for that specific season. No? So after you have the amount of dialogue or the amount of lines they have per episode, you can do the average dialogue per season. So you get the dialogue per episode, and then you group that by the character and the season, since you're not anymore grouping by the episode because you're averaging that. You summarize by getting the mean. So if you're familiar with math in general, you know what mean stands for. It's getting the average of all the count you have per episode, per character, and per season. No? And then you arrange that by character and the descending average count. So if you run that, you can see that Andy had the most average amount, the highest average amount of lines per episode in season 8 with 43.75. And say you have Dwight, in season 9 he had the most lines on average per episode across all the 9 seasons with 46. And then secondly, in season 5 he had 39.8. So if you're basing it just on this, you can infer that season 9 was a very important season in Dwight's character arc, for example. So you can infer that based on the information that you have without digging deeper. And then it's basically the scientific process. Now you make up a hypothesis based on things you see, and then you dig deeper and deeper, do the scientific method to come up with a final definitive conclusion. And then after that, this is where we visualize the distribution that you have per season. So you use the function ggplot, and then there are lots of ways to use ggplot. There are lots of documentation out there for you to be able to get through all the types of visualizations that you can do on there. So for here, we're just gonna do a simple area and line graph to combine, and splitting it per character. So I won't explain all the functions here. You can just let me know if there's something that you don't understand in the future. You can message me, or you can just Google it. More on that later. So if you run that, basically gives you this output. So across all the 9 seasons, you can see that Andy started season 3, where he was introduced as first as a minor character. Then eventually he rose up the ranks, and after his actor Ed Helms, after he got famous from being in The Hangover, that's when he got more lines. So starting from season 7 all the way to season 9, he had the biggest jump out of a lot of the characters, or a lot of the minor characters. So he became eventually one of the main characters. And Michael, he eventually gets less and less lines, but he is the main character of the series. So as you can see here, if you compare with everyone else, like even Jim, Dwight, Pam, and all the other main characters, you can see that he has the most lines, and it spikes in this season for some reason, and then it drops down later on for another reason that I don't want to explain because you might get spoiled. And you can see the other characters are fairly consistent. You can see certain things happening to certain people that may have caused their lines to rise up a little bit. So that's one of the things that you can do based on just a surface level visualization that you can do in a span of 30 minutes and stuff like that. So that's a general walkthrough of what you can do. So you can as I said earlier, it's very user friendly. You can use all your code here. You can view all of your data sets here, and then you can view all your plots here.